All right, good evening, everyone. My name is Yoel Spots. I'm a team lead at Experience, where we make live entertainment experiences come alive. And I'll use my bully pulpit to announce that we're also hiring developers of every grade and every level of experience. So feel free to talk to me afterwards if you're interested. So I'm going to be talking to you tonight about AWS API Gateway. And at the outset, I have a confession to make, which is that this topic has only a tenuous connection to Java. And so I want to thank the AJUG godfathers for allowing me the opportunity to speak even with that very tenuous connection. So what I want to take you through is talk about what AWS API Gateway is, what its features are, some use cases in the real world, because we're heavily invested in it at Experience, and talk to you about some of the gotchas. And hopefully it'll be informative and educational so that you can make some informed decisions about where this might fit into your API management solution. So the first thing we need to talk about is what is AWS API Gateway. So at the most fundamental level, it is basically a proxy that sits in between your client and between your backend service, which provides your API services. So looking at it like this, it seems pretty silly. Why exactly would you want something in the middle there, just adding another hop in the connection? It's effectively just acting as a proxy between the client and the service. So that's what we want to take a look at the next few slides to see what exactly this would give you that you are willing to live with the expense of another hop through the connection stream. So the very first thing, and I want to say at the kind of the beginning, that the first few slides are going to describe some features that you're going to get from pretty much every API management tool out there. A little bit down the line, we'll talk about what makes AWS offering special, and sneak preview has to do with the AWS integration. But first, let's talk about some of the basic features, again, that you'll get from most API management out of the box, but which AWS API Gateway gives you as well. So a couple different things here. Number one is monitoring. So you'll be able to tell how many hits there were, latency, for individual methods, throughput, over the course of a day. You can see which ones. You can set alarms to let you know if there are certain things that go above a threshold. So you can get a pretty good feel for the different usages of your APIs. Now, obviously, the other option would be that you'd have to build it into your backend service, which is really violating the separation of concerns. So you're able to move that further down along the chain, and not only that, you can get it with all of your API backends, so you don't need to build it into all of your services. You've got it for free, certain definitions of free, with AWS API Gateway. The other part here is API rate limiting. And so for certain clients, if you want to give, you've got it giving access to your API to a lot of different clients, you're able to give them only a certain number, you can throttle them at a certain point, and you can do this on a per method, on a per client basis. It's pretty flexible in terms of how you configure this. But this way, you can ensure that your backend service doesn't get DDoSed or anything like that. And for certain, again, if you are, for example, monetizing your API, you might have different levels of usage for your server, for your API. And so for different clients, you can give them a different API key. And you can configure, based upon that, what certain clients will have access to. So those are the first two things that you get from AWS API Gateway. Here's the next use case. So you can transform the request or transform the response on the way out through AWS API Gateway. It's got a pretty nice DSL for transforming the request and responses. Now, why would you need to transform the request and responses from the service? Well, a couple of use cases. Number one, imagine you've got a pretty old service. You've got a legacy service. I used to work in the travel industry, and you'd be amazed at some of the responses you get back from some of these services that are on the back end. Some of these things were written in the 70s, and the responses can be pretty interesting. And so you've got this back end service, so instead of having to rewrite the entire thing, you can transform the requests so that they look like very nice, modern REST, conform to the modern REST standards, and on the client is no the wiser that this service is actually written in the 70s. So that's one use case where you've got a legacy service. Another potential use case is you've got a back-end service which is providing input, or providing output, I should say, for multiple clients. and maybe those multiple clients expect the request response to be in different formats. And so you can have AWS API Gateway act essentially as an adapter layer where one service can provide an API for multiple clients in different formats. And so you can transform both the body of the request and the headers, as well as on the way out, you can transform the body and the headers of the response. So it's pretty flexible in that way as well. Here's another use case. Imagine you've got multiple services on the back end, but to the client, you'd like to abstract that into one nice, clean API. And so, as we all know, as services grow, sometimes different teams are working on them. And so you might have a bunch of different services, but again, you want to abstract that all the way to the client. And so you could provide this definition of one nice, clean API, which is fronting a number of services. And in fact, maybe you're exporting only a couple of the different endpoints here, a couple of endpoints there. So you don't even need a one-to-one matching. You could pick and choose which APIs or which endpoints from the different services. So up until this point, like I mentioned, everything that you get from most API management tools. Where things really get interesting is where we look at how AWS API Gateway is different. And as one might expect, the way in which it's different is the integration with all the other AWS services. So I want to talk a little bit about that. So first example is you can host your service inside of a VPC. So very quickly, if you're not familiar with a VPC is a virtual private cloud, which allows you in the cloud to host things which are essentially in your own private network. And so you can be very discriminating in terms of who has access to that private cloud. So this is not public facing. Your service is neatly ensconced to private access. And so what you're doing here is the AWS API Gateway is effectively acting as a firewall between the public client and your service, which is living in this private cloud. And what you can do here, a couple of different interesting things that you can do, is maybe you have some endpoints which you want to make public facing, and some which should only live in the private VPC. You've got other services, you've got a bunch of microservices that communicate with each other. And so this way you can provide only the API, only the endpoints that you want to make public through AWS API Gateway. It will then go into the VPC and then come out of the VPC for the public client. Another interesting use case here, which is actually something that we do, is once you have your service inside a VPC, you want to have the separation of concerns. It doesn't want to have to worry about authentication, authorization, and as we'll see in a couple slides, AWS API Gateway can provide authentication authorization. So that this guy, you don't need to worry about all the securing your different things, securing your data in here. It's nicely encapsulated in the VPC, and this will handle all the authentication authorization such that you completely separated all that and you don't need to worry about it inside of your service. So that's a very nice facility and one that we make use of. This is another exciting one as well, and although I'm not a big fan of the term serverless, I'll use it because that seems to be the buzzword. But what you could do is you could have a Lambda, which is AWS's serverless, or you don't have to have a managed servers, the way I like to term it, but you basically just write a function. And what's very nice here is you don't even have to have a backend service, nothing in EC2, nothing in Elastic Beanstalk. You just write a function which will handle the endpoint. And so here you've even gotten rid of servers altogether. And so you could have all your endpoints being serviced by one or more lambdas, so you just write functions which will handle the endpoints. And so this potentially can make things a lot easier for you depending on how you want to set things up. In this case, you don't need to worry about managing your servers. So this is something really nice which you won't get with any other API management tool because of the integration you get with AWS API Gateway. And this is something that we use heavily as well. One more thing also, you can mix and match your endpoints. And so this is something that we do. You could have some endpoints being serviced by lambdas. You can have some of them being serviced by servers, by different services. So this is in fact what we do. We have a token generation for authentication, and that's actually handled by Lambda, which goes out to our third-party OAuth provider. And you can have your other services, so there's a lot of flexibility in terms of your different endpoints and who services those endpoints. So I spoke a little bit about authentication authorization. You've got a few different choices for how you authenticate and authorize your requests. And again, like I mentioned, you have the option of completely separating it out such that your service doesn't worry about it at all. One of your options is to use the IAM, which is the standard identity management facility of AWS. And you can have, in concert with an API key, you can have AWS API Gateway use an IAM identity to do your authentication authorization. Now, this is not something that we utilize, and so I'm not incredibly familiar with this, but this is an option. This one is one I'm more familiar with because this is exactly what we do. And we, in fact, handle all of the authentication authorization at the AWS API Gateway layer. And what you could do is you can write your own custom authorizer, which is a Lambda function. And what you can do is go out to your OAuth provider and verify, validate the token. And what the custom authorizer then does is it creates an AWS policy, which you then return to the AWS API Gateway, which describes both the authentication and the authorization level, describing the different endpoints that this user has access to based upon the token and based upon the OAuth provider. And so this is something really nice. And effectively what you've done is you've created your own AWS policy and AWS identity through your custom authorizer. And from this perspective, AWS API Gateway, there's no difference between whether you've gone out to a third party or whether you're using the IAM, because it's all the same. It's all using the AWS policies. And so this is really nice because, again, you've completely separated the concern. You no longer have to do any authentication authorization at the service layer. Or what you could do is you could have different levels of authentication authorization. You could have this doing some of it and this doing some level of it. But again, the integration with AWS gives you a lot of power and flexibility. Another feature that you've got is Swagger integration. So Swagger is kind of the de facto standard for describing APIs. And in fact, this is what we do, is we describe all of our API endpoints in a Swagger file. And then at deployment time, in addition to deploying our backend service, we import the Swagger file to AWS API Gateway, which then creates the deployment for API Gateway, describes all the endpoints. And what's also really nice is that AWS has a bunch of extensions to the Swagger standard, which describes all the different integrations with the backend, whether it's a Lambda, whether it's a service. And so basically it's a way of documenting your endpoints and their integration with AWS. And so you have it all right there. And so you can use a Swagger file, which is what we do. We use it for generating documentation for our clients, as well as for deployment time. It's a self-describing document for the deployment of our API service. So that's a very nice facility as well. Of course, with any service, there's always going to be gotchas. So I want to talk about the gotchas. Just want to mention one thing also, in case this is not clear. There's no requirement or limitation in terms of what language you use on the back end. AWS API Gateway is completely language agnostic. And so you can write your Lambdas in whatever language is supported in the Lambdas, and you can write your backend service in whatever you want, as long as it can be reached by AWS API Gateway. All right, so now to the gotchas. Everything is not perfect. Obviously, there are going to be a few things that you have to worry about. And these are things that hopefully I could save you some time on that caused us some headaches. The first thing is that even though you could configure the timeout for your different endpoints, the maximum you can set it to is 29 seconds. Now, certainly that's good practice to have your API respond within half a minute, but there are times when things take a little bit longer. And what's kind of annoying is that you only know that you have a problem once you actually have a problem. And you'll get a 504 back. And what's especially annoying is that it's not as if it'll cancel the operation on the back end. Things may keep on going on the back end. And so from a client perspective, it gets back a 504, but on the back end, it succeeded, it went through the operation. And so the client may say, I got an error back, I got to do that thing again, and if the operation is not idempotent, you'll be maybe creating another user or whatever it is. And so this is kind of frustrating. Your options really are to either break out your APIs into multiple APIs or to create an asynchronous API, such as you'll then be polling or have a webhook or something like that. But again, the frustrating part is that you don't know you have a problem until you actually hit it. And it's at that point that you've got to deal with it. The second gotcha is that AWS API Gateway uses a store and forward mechanism, which means that whatever the backend is, AWS API Gateway will wait until the backend is completely done servicing the request. It will wait for the request in its entirety, capture it, and then pass it back to the client. So you might say, what's the big deal? That sounds pretty standard. Well, what you lose the ability to do is you can't use any WebSockets there, because that's WebSockets by definition is not store and forward. And also you cannot use server send events, SSE, which is a really handy way of handling, for example, bulk type of operations where responses come incrementally. That's not an option with AWS API Gateway, and there's really no workaround for that. You just have to live with the fact that it's store and forward. You don't have the option of creating a long poll. And the final gotcha to be aware of is that there is a size limit on the request and the response. It is 10 megabytes. Your payload is limited to that. And if you're using a Lambda as a backend, actually the size limit on the response is 6 megabytes. And again, you might say that's pretty big, but the reality is that sometimes you do have responses that are quite large, especially since we are limited to the store and forward mechanism. And so, again, you only know you have a problem once you have a problem, and the operation will succeed. You'll get back a 502 if you're over the size limit. So what are the options for dealing with this? Well, you have a couple of different options. Number one, again, you could split out your API such that you don't have you have smaller requests and responses. In terms of the request, another option is in terms of the request is you'd have to shunt off the body to some other place, maybe S3 or some other place, and in your API provide a URL for where to find the body of the request. On the response side, what your option is, and this is what we had to do, is you have to build in basically a proxy that lives in between your backend and AWS API Gateway, and check the response size, and if it's too large, then upload it to S3, create a signed expired URL for that S3 bucket, and return a redirect to that new signed expiring URL to S3. Works okay. It'd be nicer if there were other options, but again, as with any service, you're going to have some gotchas. So that's an option that you've got there. So that's my presentation. Hope it's been educational. Giving you highlights. Obviously, we haven't covered everything. There are some other options in terms of the backends for AWS services, but I've covered some of the highlights, and I hope at least this gives you some idea for how to approach your API solution. Happy to answer any questions you might have. Yes.
So with some of the limitations that we saw, why did you not look at other alternatives? Why are you still sticking with this?
Yeah, so it's really because of the API, the AWS integration. There's the Lambdas and being able to do it in a VPC are really compelling for us. Now, obviously for other places, you got to make a trade-off, but for us, even dealing with this was the trade-off was worth it.
So there was no other alternative that can work well with?
Not that well, no.
So one of the limitations that you mentioned is like 29 seconds is the max timeout. Is that not configurable on AWS?
No, 29 seconds is the absolute maximum. You could make it less, but this is the absolute maximum, and you can't even. It's not one. There are certain limitations with AWS that you can request them to increase it. This is not one of them.
Yeah, it's a scaling and resource utilization issue.
Yeah.
More questions?
How do you handle multiple environments, test and production? Do you need two different gateways?
So, good questions. Question was about different staging environments. If you've got a QA, a development, and a production, and so it really depends on your use case. They do provide, AWS API Gateway does provide for different staging environments within the same API definition. What we found for us is that that didn't work because we had different VPCs for our different environments, and it didn't work well with our stages. And so we actually had to create different set of API definitions. And so what we do is we have a Swagger file with basically, and we do variable substitution at deployment time depending on the environment.
Just a follow-up question.
Sure.
If you are trying to monetize an API, how do you manage the authorization in that case?
Yeah, so in that case, they've got, and it's a little bit more detailed, I'm happy to talk to you more about it, but they've got this notion of having an API key, which uniquely identifies the client, and you can map the API key. You don't need to provide that API key to the client. You can actually manually insert that into the policy through the custom authorizer. And so that way, you can monitor which clients are making which calls. But the short answer is there is a way to identify.
Does the gateway allow you to scale, like you have multiple gateways that scale as traffic increases, for example?
I mean, the API gateway itself is not going to be the bottleneck. It scales pretty heavily. Your bottleneck issues are always going to be on your own services. It's they've got it pretty. As you would expect from AWS, the gateway itself is actually, I don't want to say infinitely scalable, but that's not going to be the bottleneck.
Okay, great. Thanks. Big round of applause.
Thank you.